Hello guys, welcome to the 30-day LeetCode challenge. This is a day 9 challenge on min stack. So let's go through the question. Design a stack that supports push, pop, top and retrieving the minimum element in constant time. Okay, so if you see, these are normal stack operation: push, pop and top. And in addition to this, there is another new requirement, that is retrieve the minimum element. If you go through the function push x, which push element x into the stack, and pop removes the top element of the stack, and top will just get the top element, whereas remove will remove it, and get min retrieve the minimum element of the stack. So this is the additional function that we have to do here, implement here. So what we need to do is, along with the so the requirement here is like at every stage, so you may either push an element or a pop an element. So during each push and pop or whatever, at every levels of the stack, we need to have the data regarding the top of the stack so that we can retrieve it in constant time. So to do this, what we can do is, along with storing the value while push and pop, we can also store what is the min at that current level. So this way we can solve this problem. So what I would do is, I'll write a class called stack element. So this will have value as well as minimum at that level. So okay, so we have the stack element, and so I'll have a stack, but instead of integer I will have the stack element. So here, so this stack, instead of an integer, it will store the stack element, which, and at every of these levels it will have the val and value as well as the minimum element. So in the constructor I'll initialize this. Okay, so what do I need to do when I'm pushing the element? So I also need to track of the current minimum rate. So I'll assign it to x, and if the stack is non-empty, then so here what I'm doing is, checking the minimum, creating a variable and assigning it with the x itself, the value, and I'm checking if the stack top has the much lesser value. So if it has much lesser value, then the stack has below it many minimum elements that are smaller, so that will be the minimum element. So when I push here, so I have to create stack element. So this will have value and min, right? Min will be this current minimum. So now this will actually check the minimum that is in the below level of stack, and this happens recursively. Basically, usually the minimum will have the minimum of all the elements that are below it, and the below it the minimum will have the min value of all the elements that are below it, something like that. So at any level, if you check the this min element, it will be minimum of all the elements that are below it. So I push this current min now. So when popping the element, so I just have to check if the stack is empty, and if it is non-empty, I'll just pop it. and top is just returning the top. So we only need to return integer, right? So the value, and get min will be the top minimum element. Let's run this code. Okay, so somewhere I'm passing it as value. Where is it? Okay, here it has to be val, and this top is actually called peak. So let's run. Okay, it has to be x, right? Okay, the answer matches. Let's submit this code. Okay, accept. Fine. So there's another way wherein you can use two stacks basically to do the same purpose. One stack will keep track of the minimum elements and the other stack will contain values. So let's code that approach also, just for fun. So here I'll be having two stacks and both will be of integer, and another is a min stack that only has minimum. The constructor. So when pushing the element for the stack, I'll just simply push it, and in the min I have to make a check, right? In the first case, when the min stack is empty, I simply can push it. So in the other case, min stack is the minimum of all the elements that are below the current level in the stack. So here dot I'll peek to get the top element, and I'll get the yeah. So x should be less than equal to because there may be duplicates. So even then I'll push it to min stack. Okay, and during pop so this will maintain a minimum stack, right? So if the element that we are pushing to the stack is smaller or equal to that of the current element that is there in the current minimum element that is there in the stack, then again it will append to the minimum stack. So during pop, what I have to do is, so I can simply remove it from the stack. Now the case comes whether I have to remove it from the minimum stack or not. So if this x is equal to, so if this is the minimum element that is in the minimum stack top, this is there. So then I have to pop that. Yeah, otherwise I need not do anything in the minimum stack. So this way will maintain less space because only the smaller elements are just added in the minimum stack, not all the elements. Okay, this should be stack, and I want top of the stack, and here minimum element will be present in min stack. So let's run this code. Okay. This shouldn't be. This should be caps. Okay. We're getting the same result. Let's submit it. Yes, it's accepted.